So I'm going to explain about the writing of formula, how we write down the formula. So formula writing basically is based on crisscross method. Writing of formula of compounds. Formula of compounds. So it is based on crisscross formula, crisscross method, crisscross. Crisscross method. So the basic point is same. First we write down the, just I am going to revise it. Write down the name. Write down the name of compound. First, this is the first step. We write down the name of compound on the place, page, etc. Then, second, write down the symbols. Write down the symbols of the ions. We have to write down the symbol of ions below their name. So just we have to follow the symbols of the ions have to be written just below. And third is exchange the charges. Exchange the charges by crisscross. Crisscross method like this. We exchange the charges. Now, you all know that by default we write the cations on the left hand side. Cations are written on the left hand side. This is universally accepted. It is a convention. The name of cation has to be written on the left hand side. Name of anion has to be written on the right hand side. It is the convention. Now, so what to do? What to do? Say if there is, I'm taking the simplest example. Let it be sodium sulfide. So sodium Na plus, sodium sulfide S2 minus. Now we are writing like this. 2 minus, not minus 2, not minus minus. This is only acceptable. It is not acceptable. This minus 2 or S. These are not acceptable now. They have become obsolete. They are of no use. They don't have any validity. This is only valid. Now, when we crisscross, this charge will come to this place, this charge will come to this place. So, what will be Na2S? You know, the charges will be consumed because on molecules there is no charge. So, it will be 2 will come here. So, minus this plus 1 will be neutralized. This is the meaning that in a molecule of sodium sulfide, 2 sodium ions are present and there is 1 sulfide ion. Again I am repeating, this means that one molecule of sodium sulfide has 2 ions of sodium and 1 ion of sulfide. So this is the meaning. Now I am coming to other point. Silver chloride, silver Ag plus. In case of plus, we write, if it is 1, we write just 1. We not like this. This is wrong. Simply we mark plus sign. Then chloride like this. Crisscross the charges, exchange the charges. So it will be AgCl. You know, both are equal, so overall charge is 0. Then copper second, copper has variable valences. So just I have mentioned copper second sulfate. So here we write down copper 2 plus sulfate SO4 2 minus. So we'll exchange. So here 2 minus 2 plus will be utilized, and it will be the formula that in copper sulfate molecule, one copper and one sulfate ion is present. So this is the example. Then coming to ammonium sulfate. Ammonium sulfate. Ammonium NS4. Sulfate SO4 2 minus. Now we'll exchange the charges. Charge are exchanged. Now here it will come here, it will come here. Now here NS4 has charge of 1. But here it will come to, now it will be kept in bracket because NS4 ion is made up of 2 different elements. So it is a change that if any ion is made up of 2 or more elements, then we put in small bracket and the sign comes, the digit comes below left. And this means in a molecule of ammonium sulfate, there are 2 ammonium ions and 1 sulfate ion because the charge has to be equal to 0. So this is simply law of conservation of charges. Now I am coming to another example. Ammonium phosphate. Ammonium phosphate. Ammonium, NS4. Phosphate, PO4 3 minus. So we'll exchange the charges. It will be again here bracket. NS4 3 PO4. So this is the ammonium phosphate. Now coming to another example, calcium chloride. Calcium chloride. Calcium, it will be Ca2 plus. Chloride Cl minus. Chloride Cl minus. So you will crisscross and it will be Ca. Now here Cl2. Here there will not be any bracket. In this condition, there will not be any bracket in the chlorine because chlorine is an element. Chloride is an element and it is made up of chlorine atom. So here we will not put any bracket. This you have to keep in mind that bracket is kept only when the ions are made up of more than one element and there is the disbalance in charges. The charges are not same. Now see here. Calcium phosphate. calcium phosphate, Ca2 plus, PO4 3 minus. So we will extend here Cl3. This 3 will be here. Here there will be no bracket because calcium is an element. It is made up of single calcium atom. Now here this PO4 will be in a small bracket and this 2 will come here. Because phosphate is made up of 2 elements, phosphorus and oxygen. So this is the way how we write down the formulas. And so very simple point is that anyone can write the formula correctly provided that he or she must have learned all the symbols. If you are unable to, grab the symbols, you cannot solve. So, practice is required and like this. Then silver nitrate, silver Ag plus, nitrate NO3 minus, so it will be AgNO3. So we write like this. You keep on writing. Then sodium nitrite, sodium Na, nitrite, NO2. See the nitrite, this is nitrate. Just I have written intentionally to differentiate. Nitrate NO3 minus, nitrite NO2 minus. So we'll exchange the charges. So NaNO2. So we write like this. Another example. Barium sulfate, barium Ba2 plus, sulfate 2 minus, So here it will 2 minus, so exchange of charges. So it will be BaSO4. So 2 plus 2 minus, they will cancel. Both the charges are same. So the charges are same, so they will cancel out. And so this is the way how we write down the symbols of the different compounds. Now zinc chloride, Zn2, chloride ion Cl1. So it will be like this. ZnCl2. In this, 1 zinc is present and 2 chloride ions are present. So this is the simple implication. This is the simple meaning how we write down the formulas of different compounds. Now lead nitrate, lead 1 nitrate. Here valency is 1. So Pb nitrate. So it will be Pb NO3. Lead second nitrate. So it will be, Pb2 NO3 minus. So we'll crisscross, here again crisscross. It will be Pb in the bracket NO3 2 minus. So this is the way how we write down the symbols of different compounds. So the symbols can be written very easily and in a very convenient manner. Symbols can be written in a very convenient manner and easy manner. Just you have to keep close eye on all the symbols, all the eyes.